Now for those of you who've been living in a cave for a year or two, this is what a circularly polarized antenna looks like a little sort of pinwheel. In fact, this is a skew-planar version. It's a 4-element circularly polarized antenna. We're going to make a 3-element antenna for our FPV backpack transmitter and a 4-element one for the receiver. That doesn't really matter. You can make 3 or 4. They're pretty much the same. Now, one thing you notice about this really well-made commercial antenna from Circular Wireless is how thin the wire is, how thin these little wires are, and that means that it's quite sharply tuned. It'll be a high efficiency antenna, and that's of course quite good if you're trying to get maximum range. But to build an antenna like this, it means that you've got to exactly know what you're doing, and you have to be able to test it to make sure it's actually tuned to the frequency you want to use it on, because the tuning can be quite sharp. So we're not going to use very thin wire like that because it would make our job more difficult. What we're going to do is we're going to sacrifice some performance for ease of construction and a more predictable level of performance. So our cloverleaf antennas, our circularly polarized antennas, will not work as well as this, but they will certainly work better than the normal black whip antenna that you get with an FPV transmitter. So if you want to save money, you can build it yourself. If you really want the best performance, then you've got to go and buy something like this from what is it, Ready Made RC or Circular Wireless. These Circular Wireless ones certainly look nice, and the full review of these coming up very shortly. I've got a plan in mind for reviewing those, along with the helical antenna, which Circular Wireless have sent for review as well. And this is the helical. Now, I should mention, of course, these are 5.8 gigahertz, so we'll be able to use these antennas with the FPV backpack, and we'll be building our homemade equivalents, but we certainly don't expect them to work nearly as well as these very professionally made products. So what I'll do now is I'll show you how we build our own version of this circularly polarized antenna. And here's our shopping list. We're going to need some heat shrink, and you can buy this in a million places. I've got this little bundle I bought from somewhere in China, and it's a whole lot of different sizes. But we'll need some heat shrink that's going to fit over this RG316 coaxial cable. Now, again, you can pay a fortune for this if you buy it from one of the recognized electronic wholesalers or retailers such as Element 14 or RS Components. I think I bought some of this. It's $14 a meter or something, ridiculous price. Or you can go onto eBay and buy a big spool of it like this. I think I paid $5 for about 2 meters of it. Cheap as beans. Now, I have no doubt that the eBay product is not probably as good as the tested certified product from Element 14, but we're only going to be using very short lengths of it, so it doesn't matter if it's a bit more lossy than the stuff that you spend a fortune on. Another source of that coax is you can buy these. These are little pigtails. That is to say, they're a little lead that comes ready made up, and it has these little SMA connectors, in this case a reverse polarized SMA connector on the end. So if you buy these, they're quite short. It's about 300 millimeters, this one. It's about a foot long. And you want to build your own circularly polarized antennas to stick on one of these standard off-the-shelf receivers, for example. You can just basically snip it, and then you've got your connector all ready to screw on. But as I say, check and make sure you get the right polarity, because if you're using the RC508 or whatever they are, those little ones that Hobby King and a number of other places sell, then you need reverse polarized. If you're using the Fat Shark, what is that called? I forget what it's called. But if you're using the ones that come with the Fat Shark, you need a SMA connector, which isn't reverse polarized. So make sure you check and get the right connector, otherwise it won't work. But there you go. Those are your two options. You can use the pigtails and cut them, or you can just buy a length of this cable and make your own. And because on this backpack we'll be soldering directly to the board, we don't need an SMA connector. So this is the cheapest, easiest way to do it. But let's get down to the basics of actually building the damn. Oh, one thing I forgot to mention, of course, you're going to need some copper wire. And this is 1mm copper wire. Now, all the experts who make really good circularly polarized antennas will tell you that 1mm is too thick. It's too thick a wire to use for 5.8 gigahertz. When you try and use 1mm wire, it will not be very well tuned. But the thing is, that's a good thing, because I'm expecting that most of the people who are going to build these antennas are not going to make a particularly good job of it, because they may not know how to solder, may not be very good at measuring stuff. So the thicker the wire, the broader the tuning. And that means that the more tolerant these things are going to be of mistakes that you might make. Of course, having said that, you still need to be reasonably accurate in your measurements. So I suggest you get yourself a nice digital set of digital calipers. This is a really old set. The digits are quite small. I've had this for years. It seems to work okay. I've also got a Mutatoyo set, which are extremely expensive, and they're actually not much more accurate than this. So buying cheap Chinese doesn't seem to hurt when you're buying calipers, because you need to be able to measure some distances as accurately as you can. Now, as I say, if you're a 1/10 of a millimeter out or a 1/2 a millimeter out, it won't make too much difference. The things will still work, but they just may not work as well, or certainly won't work as well as the commercially purchased products. So what I recommend most people do is make a set yourself, try them out, and then go and buy some commercial ones and just see how much better they work, because almost always they will do, as long as you're buying a good reputable set of commercial antennas, because there is some crap out there that is being bundled up and sold commercially. But what we've got to do now is take our piece of copper wire, our pieces of copper wire, and bend them into a shape ready for putting onto this cable so we can make our antennas. Okay, now what we have to do is convert this length of copper wire into a number of shorter segments that we will bend to look like that. And why will we do this, and what's important about these? Well, this is the piece of copper that will make up the petal of our cloverleaf or our circularly polarized antennas, our skew-planar antennas. And the actual dimensions of this is quite important because they are related to the frequency on which we're operating. And what I've decided to do, what I do with all my circularly polarized antennas, is I use a center frequency of 5.8 gigahertz. 5.8 gigahertz. There. And the reason I do that is because these little modules that we're using for the backpack and the matching receiver, they work on a range of, at the bottom, about 5.7 right through to about 5.9. So what's in the middle? 5.8. So what we're going to do is tune our antennas, or cut them so that they should be roughly tuned at about 5.8 gigahertz, so that you can choose any frequency within these bands, and there's 8 different frequencies to choose from, and they'll all work reasonably well. The 5.8 one will work better than the other ones, but it enables you to use any of the frequencies available without losing too much in the way of performance. So we'll get rid of these little modules for the meantime. So what we need to know now, of course, is what are the dimensions for this little piece of wire we're going to cut. And I shall draw a bigger one for you and write down the dimensions. Okay, so here's what our piece of wire will look like. And from here to here has to be a full wavelength at the frequency we require. Now, there's a website you can go to called rcexplorer.se or something. I'll put a link to it. You'll see a link up here, probably along here somewhere. And that website's where you can go. You can type in the numbers you want and it'll produce the figures. But as I say, for this case and for everything I've tried, the figures I'm going to give you will work right across the band. And that means that we need a piece of wire that's going to be 26.5 millimeters across here, from there to there. Now, if you're in America, you probably don't understand what millimeters are, but they're really tiny things, about 1/25.4 of an inch. So go and get yourself a metric ruler or some calipers, some digital calipers like this that will work in millimeters, because you're going to have to work in millimeters to do this. I'm not going to mess around with the old-fashioned imperial measurements. So that is actually 1/2 of a wavelength. And then we need some up and downs. Now this one will be 13.2 millimeters from there to there. That's 1/4 of a wavelength. So you'd think this would also be 13.2 millimeters, but it's not. And this is where I differ from the guys at RC Explorer, because what happens is when we put this together, we're not going to be able to solder this right onto the middle of the coax. There's always going to be a little bit poking up. So we're going to make this 12 millimeters from here to here. And this is where I differ from some of the other tutorials on making these antennas, because this millimeter shorter here is quite important. It means it'll remain tuned, even though we're not going to be building it perfectly, because I know people can't build this stuff perfectly. Everybody has a limit to the tolerances, the accuracy at which they can work, and this will take that into account. So that's what we need. So we need to make a piece of copper wire that looks like that and has those dimensions. And here's one of the ones that I've made up. Now, what you can do, of course, is just make one up and copy it. So I'll leave you to work out how to do that. But you can use your digital calipers and basically just measure the gaps here like this and make sure you get the lengths right. One thing to remember, of course, is that we're using 1 millimeter wire. So if you're measuring and you're going to measure the inside like this, say you take your digital calipers and you measure the inside measurement there like that, then you need to make it 25.5 millimeters, because these measurements are to the center of the wire, and because you have 1/2 millimeter on this side, 1/2 millimeter on that side, given that we're using 1 millimeter thick wire, it'll be 1/2 mil to the center there and 1/2 mil to the center, then we need to take 1 millimeter off these figures for that particular measurement. So this will actually be 25.5 on the inside if you're using 1 millimeter wire. And while I think of it, where do you get 1 millimeter copper wire? Well, you can buy a piece of thick cable like this that's designed to carry quite high currents, and you can pull the strands out. Go to your local electrical wholesaler, ask them to have a look, find a piece of multi-strand copper wire, and you'll find that some of them have like 7 or 8 strands of 1 millimeter wire in there. You can strip it back, pull all the wire out, and then you get plenty of this stuff to make your antennas with. So there we go. What I want you to do now is to make up 3 pieces of wire this shape using those dimensions. Now this one here I haven't specified, of course, but I'd make that probably somewhere around 8 millimeters to 10 millimeters. This one isn't critical. This length here, not so critical, because you'll see why in a moment. So that's not so critical. Make it between 8 and 10 millimeters, and just make up 3 of those, and then we'll move on to the next step. So now I have my 3 identical pieces of copper wire cut to the dimensions I showed you earlier. There they are. And we need a piece of coaxial cable. This is the RG316 coaxial cable. Cut yourself a 60 millimeter length of this. We're going to make it a bit shorter when we're finished, but we need to start with something that gives us a bit of extra on the ends. Now, the reason it's that long is basically so that on the backpack it clears the airframe, and it's more than a wavelength, so it gets us out of a thing called the Fresnel zone, which basically improves the performance. It's also going to be a multiple of a half wavelength, so it means it'll be the effect of any inaccuracies in our antenna design will be reduced. They won't be quite so as important when it comes to losing power along this cable, because we're going to be using multiples of a half wavelength. So if that means nothing to you, don't worry, just follow the instructions and you'll see what happens. So the next thing we've got to do is strip some insulation back from the end of this RG316 cable. The amount we're going to strip back will be slightly more than this length of copper wire that we've got down here, this little sort of piece we've got here. Slightly longer than that, because eventually these pieces of copper wire are going to sit against the braid on our little piece of cable, something like this. We're going to solder them against the braid so it makes a nice firm connection, but we have to strip back maybe 2 or 3 millimeters more than the actual length of those bits of copper wire. And the best way to do that, easiest way, is just to get yourself a sharp knife and sort of ring bark the cable, then use your fingernails and pull off that little section of plastic like so, leaving you with, if I bring this up to the camera, hopefully the light's not very good, but maybe we'll get a focus on it. There we go. You can see how I've stripped back the insulation from that end piece there, and now we're going to cut away some of the very fine end, the very fine braid, so we've got just a couple of millimeters of the inside conductor sticking out past the braid. Now when you do this, try not to spread out the coax or the screen of the cable too much, because we want to keep it fairly tight so that we can solder it later on. So just try and get all the little dangly bits. It's a little bit fiddly, but this whole antenna making business is actually quite fiddly, so you really do have to sort of, you may want to have a couple of goes at it. The first time's probably not going to turn out very well. Now when you get to this stage, you start to realize why. Sometimes it's actually worth paying good money to get a commercially made antenna. But a little bit more to do on that side. There we go. So now bring it up again, try and get some focus again. Now you can see, there we go, that I've stripped away some of the braid there towards the end, just to leave the inside of the cable exposed. Now what we're going to do is take our soldering iron and we're going to tin all that braid. So we're going to cover that in solder. And here we go. I shall try and get this on the camera, but it's probably not going to be that easy. First of all, I've got to find my solder, which I've left laying around on the bench. So here we go. Here is the little piece. I just get the extra solder off my soldering iron, and now I'll try and tin that by heating the braid and then letting the solder flow onto it. Hopefully this will all be in shot, but I doubt it because I'm having to work backwards here with my camera. Really tricky job. So let's see what I can do here. Here we go. Hopefully this is showing up all right. The idea is to get plenty of solder on this braid, because we're going to be soldering those other bits to it later on. So there we go. I think I've done that reasonably well. And hopefully here you can see that I've soldered that braid. That braid is now quite solid because of the solder I've poured into it. And now we have to actually take this little tip here and strip some of the insulation away from the inner conductor. Again, the best tool for this job is a sharp knife. And this isn't a very sharp one, but I'll do what I can. Again, you just ring bark the inner conductor there, and you should be able to just pinch off the end with your fingernails. There we go. So now if I can get the focus on this again, you can see we have the wire poking out the end. It's a bit hard to get the focus on this. Still getting to grips with this Sony camera. There we go. See, the end of that is poking out. Now the important thing with this is you want this little gap here between the end of the braid and the start of the wire to be as short as possible. Remember, we cut an extra millimetre or so off that piece of wire. I'll show you our diagram again so you can see. You remember we made this a millimetre shorter here. I'll get into shot. This is only 12 millimetres, that's 13.2, because we're allowing for a 1.2 millimetre piece of wire poking out of our coaxial cable to keep it all the right length. And this one, as I say, is probably a little bit long, and yours will probably be a bit long too, because when you're learning it's a bit hard, when you're practicing it's a bit hard to get it right first time. But to make it obvious, I'm going to leave this one a little bit longer. And of course the next thing we have to do is tin that, put some solder on it so that we can solder to it. Let's give that a go. This should be a nice quick operation. Clean your solder tip, and you want plenty of solder on this little end here, as much as you can actually get to stay on there. That's enough. And if I hold it up to the camera again, hopefully we can see that I've got quite a reasonable little blob of solder on there, because we're going to be soldering to that later. So there you go. If there's any loose wires around the braid there, now's the time to actually chop them off and make sure there's no chance of a short circuit between the inside conductor and the braid. Next step is to do some more tinning, and we've got our pieces of copper wire. We need to tin the long piece here, which, as I say, heat the wire and put the solder on, and try and get a really good coating on there. You want that to be really all soldered up. Here we go. You notice that I'm not screaming around like a girl, because after years of soldering, my fingers are almost immune to high temperature, so I can hold this copper wire in my hand without getting burnt. It's wonderful. Other people, when you're doing this for the first time, you're probably going to want to use a pair of pliers or something to hold the copper wire, because it will get very hot. Until you get the necessary calluses, you're just not going to get the results that I'm getting here. Okay, you want that plenty of solder on there, because we're going to do what we call sweating these parts together later on. That requires not adding extra solder, but having enough solder already on the parts that you're joining. And notice it doesn't take long when you're doing this if you've had a bit of practice. You find that really good people who do really good soldering tend to do it really quickly. That's when you spend too long and all that flux is burnt away, that's when you start having problems. So I've now tinned these ends. I've also got to tin the other end, so we'll do that as well. And on this end you want to get a really nice ball of solder if you can, like that. I'll hold this up to the camera so you can see. Now you notice here I've got a ball of solder almost on the end of this piece of wire. Hopefully it will focus soon. Come on, focus. We've got a ball of solder on the end of that piece of wire, because that's going to be all the solder we need to get the whole thing joined together. And this end I'm holding with my fingers, that's tinned as well. Do that to all three pieces. And again, as I say, you can see now why the commercial circularly polarized antennas are so expensive, because it's such a fiddly damn job. But if you've got plenty of time and no money, then make one yourself like this. Here we go. Our three pieces of wire are all now tinned and ready to go. Now we've actually got to join them onto this piece of coaxial cable. And that's where it starts to get rather tricky, because now we've got to join them up in a way that means they all line up properly. And to do that, I'll just clear a bit of space here, because we've got little bits of wire everywhere. Cleanliness is important with soldering. What we have to do now is lay our pieces of wire against the braid there and just apply enough heat to sweat them together, just hold them, they'll just hold briefly. I'm trying to do this without getting in the way of the camera, which is going to be a little bit of a trick, I think. And this is where having a good iron is so important, because the heat, I'll put something on the other end to hold it down. The heat of the iron, if it's temperature controlled, you'll have plenty of heat, but you won't overheat anything. So heat this up and it should start sweating. If I take it off, with a little bit of luck, as you can see, that's actually stuck. Because what I've done is, by heating the copper wire, it's melted both the solder on the copper wire and the solder on the braid underneath. Now I can take the solder and I can actually just add a little bit near the end to hold it together. This is easier to see when you're looking really close, but of course I can't get the camera right in there, but I'll show you what I've done here. Now again, if we can get some focus on this, there we go. You can see that I put an extra blob of solder at the top there to hold it. The bottom is where I've just sweated it, and that'll do us for the time being. Now we need to do 3 of them, all 3 of them, which it gets harder as you go on because they have to be placed at 120 degrees to each other. But notice also that I've lined it up so that the right angle of that wire, that vertical piece of, or this piece of wire here, no, this piece here, is as close to the edge of that braid as I can get it. And that's quite important. I should have put this on manual focus. It's quite important to have it so that the gap between this horizontal and that piece of wire in the middle is the minimum you can get it to. Now here's the next one. Remember, it has to be at 120 degrees, so you've got to sort of guess this. I don't expect you to get it dead right. And I'll just sweat this onto here. As you can see, I'm heating up the copper wire, and it will then hopefully, and remember, you may have to use pliers because you probably won't have the same iron covered fingers that I have. There we go. Your fingers will be going ouch by the time you get this far. So I've got 2 on there. That's probably not a 120 degree angle, but I can adjust that later on. And then we've got 1 more to go, but I'll just, as I say, just put a little dab of solder near the top on here to hold it in place. Try and keep the copper wire as close to the braid as you can here. Pinch it in so there's not a big gap. But if there's a gap, I mean, don't worry too much. Your first attempt's going to be pretty poor, and you'll have to practice a few times to get it right. So these materials are cheap. Don't worry yourself too much. Okay, you need a little bit of extra solder at the top there, but not too much. And as you can see, I hope, get the camera focusing, there we go. That one's also got a little bit of a tack at the top. The other one's got a tack at the top. So there we go, we're starting to get this together. 1 more to go, and that's going to be the hardest one because we can't really rest too much on anything. So just make sure I've got enough solder on the end. You can't have too much. You want a nice big blob because that's going to melt down onto the braid. In fact, in this case, I'll just put a bit more down here as well. Make sure that braid's got plenty of solder on it. And this is where you need to have a soldering on that has enough heat, because if you don't have enough heat, it'll all go cold and you won't actually get any soldering taking place. So now, get me asbestos fingers out. Put my pliers down there to hold things in place, try and keep everything lined up. And away we go. There we go. So, as you can see, it looks pretty crap at the moment. I haven't got the angles right, but once you get these soldered on, you can actually twist the wire and it lines up quite nicely. So I shall finish the soldering, get these things lined up as best I can, and then we'll do the rest of the soldering. Okay, this is not a good aerial, but it will still work. The thing is, these are quite tolerant. Despite what you might read, you can make a few mistakes and it doesn't make a whole lot of difference. They'll still work better than your little whip antennas that you get with your FPV gear. So now all 3 of my wires are tacked against the solder braid, and what I'm going to do now is I'm going to get my soldering in it. I'm going to flow solder in here to make a nice continuous join, so it makes it physically strong as well as electrically connected. You probably won't get a very good view of this because it requires a lot of farting around. If you've got a vise, you can use a vise, might make life easier, but I'll just go ahead and do it freehand, as I have done for years. Because we previously tinned all this, we don't actually have to add much in the way of solder, because we're just heating what's there and it will just flow to join everything together. But as I say, it's a bit of a bloody rat's nest trying to do this, a bit of a nightmare trying to get this all lined up, and this is where just practice is what you take. But again, as I say, you'll really appreciate the benefit of buying something off the shelf when you've done this a few times, or certainly on the first time. So here we have it. It's all soldered up. Try and get a shot for you there with a bit of focus on it. All the wire is soldered to the braid, and this is really a bit of a dog's breakfast, this one, which will make you feel better when you do yours, because notice I've got these two that are facing you now too close together, which means this one's too far apart. But the angles are also not quite 120 degrees, as you can see. You have to do a bit of mangling to get those together. But if yours is as good as this, then you can be happy that it's going to work. Typically these aerials on the backpack and the receiver that I'm going to show you how to build in the few more videos, they'll give you up to 2 kilometers of range. So, you know, there's plenty of room for error. And the next step is to make sure that all your little lobes are at 120 degrees, so evenly spaced, looking from the top here like this, and make sure that the wire comes out at right angles to the coax itself, so that you get everything sort of nicely flat. Should be a flat line across. This is close enough, because now we're going to bend it into the cloverleaf shape, and the RC Explorer one shows you bending it before you solder it up, but I find much easier to bend it once you've got it soldered up, because once you've got this solder joint done down here, then the bending is a piece of cake, and it's also quite rigid. You can't actually rip the braid off or anything. It's really, really strong this way. So now you need to get your long nose pliers that we had before, and you need to bend these at 45 degrees. But first of all, you need to decide you're going to go right hand or left hand polarization, because looking at the antenna like this, you can bend these wires that way, or you can bend them that way. We'll do right hand, because that's actually the most common polarization. Everyone seems to use right hand polarization. So what we're going to do is take each one in turn and bend it through about 45 degrees. And you can eyeball this, you can make it more accurate, you can use a protractor if you want to. But as I said, I think the accuracy is grossly overstated. Unless you're looking to do some real record breaking, then near enough is often close enough with these. Make sure you keep it at right angles, so you have to sort of tweak around with the pliers and get it so that it looks, so that all the angles look right, and make sure you don't bend stuff too much. Just get it looking pretty much right, 45 degrees on these, and you'll end up with something that looks like this. See, your little wires are bent at 45 degrees, and when you look down, they're still at 120 degrees. So now we have to put in a curve into this piece here. This has to be curved to bring this around, so that these little ends here should all end up touching the tiny little piece of coax that's still sticking out of the middle here. So now, the way I found to do this, the easiest way to do this is just progressively, with your long nose pliers, just give little tiny bends in here, like this. If I can do it on camera, try and get it in frame. Little tiny bends, just a little bit at a time. Doesn't have to be perfectly smooth, but obviously smoother the better. Start at one end and work along. Bit of a job, like so. Try and bend it so that you're only bending in one plane. You don't want to bend it in another plane, so that you end up. Now you notice here when I've done this one, it's actually come out a bit wrong. It's actually come past the coax. Now if I hold it up a bit closer, try and get it in the close up, you can see it's actually gone past the center. So what we have to do there is actually readjust our bends to make sure that it lines up. And the best way to do that is to increase the radius of the bends at the base here and decrease the radius at the tip. That will bring it more into line. As I say, you need to make sure that it's still flat. So you play around, you'll get the hang of how to do this. It's just a bit of experimentation. The copper wire is very ductile and malleable, so you'll soon learn how to get these angles dead right. And if they're not dead right, it's not that really bad. It's not going to be the end of the world. But when you've finished, a bit more to do here. It's all a bit of a job. Sometimes you just have to use your fingers as well. It's just the easy way to do it. Okay. When you've finished, this is a pretty rough one, I've just done it quickly. When you've finished, you'll see that the wire actually lines up with that piece of coax in the middle. It just sits on it. Just stays there all by itself, which is going to be important for when you come along to solder it on later. So now you've done one, you've got to do the other ones the same. Here we go. This is all done now. Focus camera, focus. This is all bent, and you'll notice that the pieces in the middle are all touching the center wire. Try and get a close-up shot of that. Yes, you'll see that the three center wires are actually touching the inner of the coax there. If you look from the side, they're not actually shorting out, but they're all touching that center wire, and that's important. And the whole idea of making these antennas, if you want to make them as efficient as possible, is to keep this distance here between that connection and the braid of the cable, this little bit in the middle here, has to be as short as possible. Preferably, in theory, it should be perfectly in line with it, but you're never going to do that because you'll always have to have a little bit of a gap. So there we go, they're all touching. Now all we have to do, because we've got solder loaded on the inner wire and on these ends of the petals, is heat it up. And it should all flow together, it should all sweat together. So let's give that a crack. I'm probably not going to get this on video because it's too hard to keep things in frame while I'm trying to solder it, but I'll solder it and show you what it looks like when I'm done. Okay, so there we go, I've done it. It's a bit bodge, it's not my best job, not my best work. I don't work well under pressure, but as you can see, we've soldered that, all those three wires to the centerpiece, and it's important that that blob of solder in the middle is nice and smooth, and that's where the flux comes in. If you do it quickly, then the flux won't boil away, you won't get little spiky bits poking out, it'll just flow nicely and give you a smooth blob, which is exactly what you want. And there is, for all intents and purposes, our circularly polarized cloverleaf antenna for 5.8 gigahertz. Except we need to make it look a bit tidier. So we'll put some heat shrink on this piece here, make it look nice. Get yourself a nice piece of heat shrink that's big enough to slide over the whole lock, stock and barrel. Push it up to the end, and you can use your heat gun or the barrel of your soldering iron to shrink that down so that it's nice and tight, and makes the whole thing look rather pretty instead of leaving that horrible exposed open wire there. There we go. Heat guns are much better than, I don't have my heat gun here at the moment, so I'm just going to use my soldering iron to shrink down the heat shrink, and there you have it. There it is. There's the, now at this stage you might need to adjust some of the angles because they may have changed a little bit, but that's a rather poorly tuned circularly polarized cloverleaf antenna for 5.8 gigahertz. And that, as I say, using these antennas built roughly to this kind of quality, which is not that high, you can get up to 2 kilometers with the FPV backpack. You're going to need one like this for the transmitter, and the one for the receiver, which is called a skew-planar, is the same as this, except we use 4 of these pieces of copper wire and we put them at 90 degrees instead of 120 degrees. But what I've showed you on this video, you just do the same thing but with 4 pieces of copper wire. Dimensions are all the same, and there you have it. Now obviously we've got nothing on this end. If we had made this antenna for plugging into an existing 5.8 gigahertz receiver, we would have used one of those little SMA pigtails that I mentioned before, and would have the pigtail, the SMA connector on the end here, or the RPSMA, depending on what type of gear connector your gear uses. You'd have that sitting on the end here. But we're going to use just the bare wire because we're going to solder this directly to our backpack board, which reduces the weight and also reduces the losses, because every time you have a connector, you end, oh, my phone, sorry about that. Every time you have a connector, you end up with a certain amount of loss. This is the lowest loss. And we're going to trim this down to a length of, 53 or 54 millimeters, because that's going to make it a multiple of a half wavelength and effectively make for lower losses between the antenna and the actual transmitter itself, just in case the coax isn't that crash hot because you might have bought cheap Chinese stuff. So there you go. It's the first part of the build video. That's our cloverleaf antenna. And next time we'll look at doing the first part, or what we might do next time is actually put the leads on the camera, modify the leads that come with the security camera 2600 TV line camera with wide dynamic range, and put that on, put a plug on that so we can plug it into the backpack when it's done. But have a try with these. You may find you throw the first 4 or 5 out, but eventually you'll get one that's near enough. And as I say, for all its ugliness and faults, that one is actually near enough.